Hi everyone. Let's take a look at the following limit. Find the limit of 1 plus 1 divided by x in brackets to the power of x as x is approaching to infinity. Now the first step is you can plug it in, and I'll put this in quotation marks. This is going to give you 1 plus 1 divided by infinity in brackets to the power of infinity. And what happens is in the row of limits, 1 divided by infinity is going to be 0, and you end up with 1 to the power of infinity. Now, you got to be mindful there are 7 types of indeterminates. And for the record, I'll put this on the side in case you're curious. The 7 types of indeterminates include 1 to the power of infinity, infinity to the power of 0, 0 to the power of 0, 0 times infinity, infinity minus infinity, and of course the most classic types are 0 divided by 0, infinity divided by infinity. So what this means is you cannot just plug it in and work it out. The second step is to think about a rule, and this is not just any rule. I would say this is one of the best rules you can use that can help you to solve most limits. And the name of this rule is called L'Hopital's rule. Now, let's talk about what this looks like and how we can apply it in this example. If there's a function, let's call this f of x divided by g of x, and you're taking the limit of this function as x is approaching to a, what happens is sometimes you're going to get 0 divided by 0, sometimes you might get infinity divided by infinity or any other types of indeterminates. Then what you can do is you take the limit of that same function, except you're going to take the derivative of f of x, so f prime of x, divided by the derivative of g of x, which is g prime of x, and see if this works. Now, sometimes once you differentiate the numerator divided by the derivative of the denominator, it works and you can stop. Sometimes you're going to keep going, and it might take 2 to 3 times until you get an actual number. So when you go back and say, in this example, we're going to apply L'Hopital's rule. Now, you got to be mindful because if I want to take the derivative, there's 2 things you want to think about. Number 1, recognizing that this could equal to something, let's say this is equal to L, which equals to the limit of 1 plus 1 over x to the power of x, as x is approaching to infinity. Now, you cannot just differentiate this because the base contains x, the exponent contains x. So you have to ln both sides. So this is also under the topic logarithmic differentiation. And what happens is when you ln both sides, on the left-hand side, it's going to be ln of L. On the right, you can take the limit as x is approaching to infinity, ln of 1 plus 1 over x to the power of x. Now, if I go back and write down 3 rules that you should think about in terms of ln x, these rules include, and again, for your reference, one of them is going to be ln of a to the power of x. The exponent could be brought to the front. So ln a to the power of x equals to x times ln a. Other rules that will be meaningful, which you're going to see in a moment, includes e to the power of ln x equals to x. And of course, ln of e equals to 1, and ln of e to the x equals to x. So I wrote down a couple more for you. So what I'm saying is, in this case, you can apply this first rule, bring that exponent to the front. So look what happens. This is going to be ln of L, which equals to the limit as x is approaching to infinity, and you're going to bring x to the front. Now, what you can do is you can take the derivative. And of course, if you look at this carefully, again, I'm going to apply L'Hopital's rule. So you can rewrite this in terms of ln L, which equals to the limit as x is approaching to infinity. Keep the ln of 1 plus 1 over x in the numerator. X, which is the same, x is the same as 1 divided by 1 over x. So again, notice here, if I did plug in infinity, that's not going to give you a number. So this is why I can apply L'Hopital's rule. So I'm going to take the derivative of the numerator divided by the derivative of the denominator. So if I differentiate ln of 1 plus 1 over x, that's going to be 1 divided by 1 plus 1 over x times the derivative of 1, which is 0, plus the derivative of 1 over x, which is exactly negative 1 over x squared. So you see how 1 over x is x to the power of negative 1. When you apply the power rule, that's negative x to the power of negative 2, or negative 1 over x squared. Likewise, if you think about the derivative of 1 over x, that's going to be negative 1 divided by x squared. So notice we can cross these out. That's going to be 1. I go back. Step 1, I'm going to plug in x to be infinity. I'm going to put this in quotation marks. That's going to be 1 divided by 1 plus 1 over infinity. Again, in the row of limits, 1 divided by infinity is exactly 0. So this means ln of L equals to 1. But remember, your goal is to solve for the limit, which means you want to find L. The opposite of ln is to take e, in this case, e to the power of ln L on the left, e to the power of 1 on the right. This means L is exactly e. So I'm saying right now, the final answer is going to be e. Now, of course, what you want to do is develop that dual mindset. So in case you're thinking, I solved it algebraically, but how do I know for sure this makes sense? What I would say is spend that 1 extra minute, draw a graph. And once you graph this, you will see how this matches exactly the answer we have right now. So what I would say is start with the graph f of x, which equals to 1 plus 1 divided by x in brackets to the power of x. And it's going to look, roughly speaking, something like this. So let me change the color for your reference. The graph is going to look something like this. Again, it's a sketch. It's not a perfect graph, but it's good enough to show you what we're trying to do here. So there are two asymptotes. One's vertical at x equal to 0. The other one's going to be horizontal at y equal to e. And technically, if you think about the limit, as x is approaching to infinity, which means when you go to the right of the graph, what happens is approaching to e from below. So if you like, you can say from below, but that's more of a bonus idea that I'm adding in for you. So again, the final answer is E. If you find this video meaningful, it's adding value to your math life, please consider to comment, like, share, and subscribe. I hope this makes sense.